Good morning, class, and welcome to Lesson 4.4, Simplifying Algebraic Expressions with Exponents. We're going to start with warm-ups, ladies and gentlemen, which have just numerical expressions in terms of how to solve or simplify with exponents. And then we're going to take the same steps we use in our warm-ups or that we used last class to then apply to algebraic expressions. So instead of having just numerical values within the brackets or within the exponents, we're now going to have some algebraic expressions. So there's going to be some letters, and it gets a little harder. So hopefully you have a good foundation here with using the exponent laws and tying in our radical work as well. And we're going to move that forward into algebraic expressions in our lesson today. So let's start off with our warm-ups. Looking at one, it says to evaluate, express your answers in rational form. That means it can't be in exponential form. So you're either looking for a fraction answer or a whole number for a rational form. Looking at 1a, we have a fractional base all raised to the power of 1/2. Just remember, folks, that is the square root. If you simplify that through. So the exponent applies both to the numerator and the denominator. So it's going to be the square root of 49 divided by the square root of 81, which equals 7/9. Looking at example 2, there are two ways you could solve this. Okay, I'm going to use the BEDMAS method first, where I'm going to solve within the brackets. And the question says, hey, how do I find the third root of -125? Plug that in your calculator, ladies and gentlemen. So it's -5, all raised to the -3. Just to double check and backtrack, ladies and gentlemen, I know when we dealt with quadratic formula, and if we had negative, for example, 16 under the square root, that would not produce an answer, because it's really, when you take a look at the root, it's to the power of 2. And remember, a negative times a negative gives you a positive, so there's no way you could end up with a negative result. But you can gladly take an even root of a negative number. So the third root of -8, plug it in your calculator, folks, and you should get -2. Likewise, the third root of -125, so the third root of -125 equals -5. That's again just plugging it in your calculator to get that work. All right, back to our solution here, ladies and gentlemen. We now realize that we have a negative exponent, so we're going to make that positive by flipping the fraction, okay, and making it positive, positive exponent. And then we'll solve, so it's going to be 1 over -125. But remember, folks, it's bad form to put the negative in the denominator, so you either put it out front or up top. Okay, so that's from below. All right, second step, ladies and gentlemen, or second method you could do this, guys, is you could argue that, hey, in order to simplify within my initial within the big brackets, I've got a power of a power law. So you could actually do power of a power, so I'll use P of P for short form, so you know what I did here. Okay, so what I'm going to do is leave my base the same, and when you multiply -3 times 1/3, that gives you -1. Then realizing, hey, ladies and gentlemen, that's a negative expression, so we're going to have to flip it. So it's going to be 1 over -125, and then realizing that you cannot have a negative denominator in a fraction, so you should bring it out front or up top. Okay? That's example B. Example C, folks, we have a fraction of 100 divided by 121. And remember, the square root applies to both the numerator and the denominator. So square root of 100 divided by square root of 121, because you can break that up. And that's going to give you 10 over 11. All right, looking at example D. Okay, this could be solved again two ways, depending on what method you chose. I will first change my expression to exponential form to help me. So I know my base is 9, I know my root is 4, and my exponent is -2. I can then simplify my exponent to -1 over 2, putting in the lowest terms. Then I realize, hey, it's negative, so I'm going to make it 1 over 9 to the 1/2. Then I'm going to realize, hey, I can put that in radical form, which is the square root of 9. And that becomes 1 over 3. That's one way you could have solved it. The second way is to leave it in radical form and to first of all realize, hey, I've got a negative exponent here. So how do I address that? I'm going to make it 1 over 4 to the 9 squared. Okay? Make it positive. Then I'm going to say, hey, work inside my square root, which is really like a bracket or an exponent. So it's going to be 1 over the 4th root of, what is 9 squared, ladies and gentlemen? It is 81. And then I plug in my calculator. The 4th root of 81 is 3. So your final answer is 1 over 3. All right, looking at E. Please don't be frustrated when you see a decimal like that. Transfer it to a fraction. So we're going to have 16/9 all raised to the negative 1/2. We notice that we have a negative exponent, so we're going to flip the fraction. So it's going to become 9 over 16, all raised to the power of 1/2. Just remember, power of 1/2 is actually the square root of both your numerator and your denominator. So you should have a final answer here of 3 over 4. All right, last example. Although it looks hard, I think it's one of the easiest ones. I'm testing here to see if you know if the negative sign is within the base or outside or out front the base. So looking at the numerator, ladies and gentlemen, the negative sign here is outside the base, so we leave it out front. And then we calculate, hey, what's the 3rd root of 512? Plug it in your calculator. You should get 8. Divided by, looking at our denominator, ladies and gentlemen, the negative sign here is within it. So you need to make sure you include it when you take the 5th root of negative 1024. And that's going to give you an answer of negative 4. To simplify here, ladies and gentlemen, a negative times a negative divided by a negative is a positive, and 8 divided by 4 is 2. So again, we're going to take these various laws that we just reviewed and carry them forward with algebraic expressions. So we're going to be simplifying today. We're just not going to solve. Just have to pause for a second. All right, guys, sorry about that. Little pause there. Okay, let's go with today's lesson, 4.4, simplifying algebraic expressions with exponents. So what you'll notice here, if you just quickly glance at questions A and B, is instead of having just a numerical value in here, we now have algebraic expressions. We'll still apply the same laws, okay? And we're going to use BEDMAS now that we have algebra to help us solve it correctly, okay? And in grade 10 or maybe grade 9, you may have found it easier to break it into 3 parts because it can get complex. So I break it into, when you're doing multiplying or power of a power or taking a root, break it into 3 parts. It's going to be easier for you. So you break it into the sign, the numerical coefficient, then deal with the variables and the exponents. And just remember your exponent laws, and also, folks, radical laws are tied into exponent laws as well, simply because a radical can be expressed as an exponent and vice versa. All right. When we simplify rational expressions, we want to make sure that when we're finally done, that there's no negative or fractional exponents. So you may need to change your fractional exponent. If you do have a fractional exponent, change it to radical form. That's all. If you end up with a fraction as your exponent. All right, let's take a look at some of this, ladies and gentlemen. I have 5 questions for you today. We'll see how we do. All right, 1A. First thing we need to realize is using BEDMAS is we have to deal with the exponents before we do our division here. So we're going to deal with the numerator separately and the denominator separately. So taking a look at the sign, it's positive times a positive because I'm squaring it, which will be a positive result. 2 times 2 is 4. And then when I look at my x, I realize I've got a power to a power law. So it's going to be x to the negative 3 times 2, which is negative 6. And when I look at the y, I've got y to the 4 times 2, which is the power of 8. All right, now we're going to take a look at the denominator. With the denominator, be careful here, we're not taking things squared, we're cubing it. So a positive times a positive times a positive gives you a positive. 1 times 1 times 1 gives you 1. Now when we look at x, we realize that it's x to the 4 times 3, which is 12. And then we're going to look at the y to the negative 2 times 3, which is negative 6. All right. Next thing we're going to do, ladies and gentlemen, is we're going to simplify by looking at our exponent laws, the division law in specific. Okay? So when we take a look here, positive divided by a positive is a positive. 4 divided by 1 is 4. Taking a look at our exponent laws here, we're going to divide, which means we're going to subtract our exponent. So it's going to be x to the negative 6 subtract 12, which is negative 18. And y, we're going to take a look at this. It's going to be 8 subtract a negative 6. Remember, when you subtract a negative, you're actually adding. So it's going to be y to the power of 14. Let's double check. Do we have any negative or fractional exponents? Well, we have one negative, and that's our x. So to simplify that, or to fix that, we're going to leave the 4 on top because it's positive there. We're going to leave the y to the 14th. And then as a denominator, we're just going to write x to the 18th. So basically, I've just taken the reciprocal of the x to the negative 18th term. Good. Let's take a look at our next example, b. Okay, again, using BEDMAS, we have to multiply first before we can divide in this case. So we're going to take a look at the sign. A negative times a positive is a negative. 3 times 4 is 12. M times m squared is m cubed. And n times n is n squared. Divide that all through by 2m cubed n. Now we can simplify the fraction. So a negative divided by a positive is a negative. 12 divided by 2 is 6. The m to the powers of 3's, they cancel out. And we left with n. So our final answer is negative 6n. All right. Now we're moving on to, I would say, more tricky or more difficult expressions. Simply because we look at our exponents here, and they're a little difficult. However, the good news in this case, folks, is the base is still the same. So notice in C that we still have our base as x, so it's going to be easier for us to evaluate or simplify. Looking at our order of operations, we need to multiply the numerator before we can do the division. So when we multiply with the same base, we add the exponent. So you've got 2n plus 1 plus 3n minus 1. Okay? Good news is when we go to collect like terms that we're adding these and the expression won't be so difficult. So let's simplify the numerator now. If we had removed the brackets, you could do that on a separate margin or realize that they just stay the same. How many n's are we going to have as part of the exponent? We're going to have 5n. And what happens to our constants in the exponent? They actually cancel out. Divided by 2n minus 5. And now we can apply our division law, ladies and gentlemen. So it's going to be x to the 5n subtract our denominator exponent, which is 2n minus 5. And we've got to be careful here, ladies and gentlemen, because it is a negative when we're subtracting. So we are going to have to perform our distributive law or just change the signs. Okay, so our final answer here, guys, is going to be x to the power of 3n plus 5. Good job there. All right, D. Although D looks tricky, I say it's one of the easier ones on the page. Maybe not as easy as B, but definitely easier than C. Okay, so write it out and let's do that one together. Okay, looking here at our exponent, folks, that tells us that's the third root. So just think, and you can do it in the margin if you want. What's the third root of 27? Okay, the third root of 27 equals 3. So I'm going to have 3. And then when I go to look at my a, it's power of a power. Again, use your fraction button if you need to. Or what's negative 3 times 1/3? It's negative 1. Excuse me. Now let's take a look at the b exponent. We have b to the 12th times 1/3. So really that's 12 divided by 3, which gives you 4. All right. Taking a look at the denominator, folks, it's the square root because it's 1/2. Okay, so the square root of 4 is 2. And we look at a, again, it's power of a power, so -8 times 1/2 is -4, so we're halving the exponent. Like b, if you take 6 and times it by 1/2, it's going to be b to the power of 3. All right. Last line, let's use our exponent laws here to divide. 3 divided by 2, just leave it as 3 over 2. Okay? And when we do our exponent laws, for a, it's going to be a to the -1 subtract -4. Remember, when you subtract a negative, it becomes a positive. So you're going to end up with a equaling 3. And again, do that stuff on the margin just so it doesn't, gives a nice flow for your work. And when you simplify b's, you're going to just end up with a power of 1, so it's just b. So your final answer is 3a cubed b divided by 2. All right, here we go, ladies and gentlemen. Are you ready for the big challenger? This is the last question, and it's a tricky one. Okay, so let's take a look at this. All right. Looking at the brackets, folks, I want to simplify within the brackets. In order to do that, I've got to get the bases to be the same. Currently, I have roots that aren't like terms, so we're going to have to put it in exponential form to see if I can then simplify inside the brackets. Okay, so I'm going to put it in exponential form. So if I have x, I'm going to know that my root is 4 and my exponent is 3. And when I look at my denominator, I know my root is 3. Oops, sorry. My root is 2 because it's a square root, and my power is 3. That's all raised to the power of 3. I'm just going to move sideways this time just to save some room, guys. It doesn't matter to me if you go across or down with this expression. I probably, because it's longer, will go across and then down. All right, looking at my expression inside the brackets, I know I now have the bases as x, so I could subtract those exponents. But in order to subtract them, I have to have a lowest common denominator. So it's going to be x to the 3/4 subtract, take 3 over 2, and how do you get that to a denominator of 4? That's going to be 6/4. That's all raised to the power of 3. Now I can subtract my exponents because they're like terms now. So it's going to be -3 over 4 when I'm done subtracting. Now I can use my, because the, apologize for that pause. Now, since inside the bracket is simplified, now I can apply my power of the power law. So it's going to be -9 over 4. Okay. We notice that it's negative, ladies and gentlemen, so it's going to be 1 over x to the 9/4. And remember, folks, it's improper to leave your simplification with a fraction exponent, so just change that to radical forms. It's going to be 1 over, it's the 4th root of x, all to the power of 9. Another way I would accept this, which is perfectly simple or perfectly acceptable as another way of showing this, is the 4th root of x, all raised to the power of 9. So I could accept either answer here. All right. Okay. Here ends today's lesson, folks. Your homework is page 236, number 2, 3, and for 4 to 9, do A, C, E, etc., all the odds. Try 11 and 14. Have a great day, and please come see me if you need some help. Bye-bye.